What do you think of when you hear the words open source? Well, since this is a DevOps Days conference, I'm pretty sure it's something positive, like altruism, free software, or community. Now, we have all these warm, fuzzy feelings around the ideals of open source, but the implementation of these ideals can be very difficult. And that brings us to the question, what makes a project open source? Now, I think for some people, a project becomes open source when it is uploaded here to GitHub. If it's public, it must be open source, right? Well, technically it might be, but in my experience, projects that stop here with being uploaded to GitHub tend to die. Sure, someone somewhere might use it, and I don't want to discourage you from sharing code to GitHub, but it is one thing to upload a project to GitHub and call it open source. It is quite another to commit to governing a community of users and contributors, to shepherding that project throughout its lifespan. Now, it almost goes without saying that open source governance is hard. That's frankly probably why you're sitting here listening to a talk on it. And the reason it is so hard is because in open source governance, technical and communication skills are intertwined. Both of these skill sets are constantly required at the same time. You cannot have a successful open source project with only one or the other. Now, the hardest parts of open source are not the technical parts, nor are they necessarily the people parts. The hardest parts of open source are the places where humanity and technology intersect. Now, even though these are the hardest parts, they are also the most vital. They are what separate a successful open source project, a project which evolves and grows and continues to expand its value, from an unsuccessful project which is shared to GitHub and then dies. Now, sometimes when I come to DevOps events like this, I find some people just desperately want to be told that embracing DevOps will magically make everything easy, that success in their business will suddenly become effortless. Now, unfortunately, even DevOps will never make running a successful business easy, but it will make it possible. Open source governance is very similar. It can sometimes seem like an impossible job. Even though it may never be easy, successful open source governance is possible. The reason I'm here today is because I have experienced this success myself, and I want to help you be successful in governing your own open source projects. And with that, I'm Nell Shamrell Harrington. I'm a senior software engineer at Chef Software. I'm also an open source contributor and maintainer, most notably on Supermarket and Habitat, which are both projects that come out of Chef. You can tweet at me at @NellShamrell or email me at nshamrell@chef.io, and I will put this contact info back up at the end of this talk. Now, in my experience in open source, as a user, contributor, and maintainer of multiple projects, I found the hard parts can be condensed into three main categories, and I call these the three duties of open source governance. And the first is to make it easy to contribute. Now, this might sound simple, but it's not simple when you realize how many different types of environments are out there. And the second duty is to assist users with the project. As the maintainer, you are on the front lines of answering requests for help. And then the third is to manage contributions to the project. Now, these might sound pretty obvious, and the ideas of them certainly are, but when you get into the nitty-gritty of implementing them in the real world, it can be anything but obvious. And that's what this talk is about. The hard things that come up in the real world when you are involved in open source governance. So let's start with that first duty, making it easy to contribute. Now, when we're experiencing those warm, fuzzy feelings around the ideals of open source, we tend to think contributing involves two things. The first is finding a project on GitHub, clicking that fork button, cloning that fork down to your workstation, and then making changes within that fork. And then next is you submit those changes in a pull request. Now this seems amazingly simple from the outside, but there is a lot that happens in between these two steps that we don't always think about. In particular, one of the hardest parts of contributing to open source is getting any development environment set up at all, let alone one that is consistent with other contributors. And furthermore, once you have the development environment set up and make changes, you then have to test those changes. And if setting up development environments on inconsistent workstations is hard, running tests on inconsistent workstations is even worse. Now, some projects try to get around this by saying we only support certain types of workstations. And while this might help mask the problem of different development environments, it also significantly narrows down the list of potential contributors. And it therefore hinders this first duty of making contributing easy. Now, one solution, which I have seen be very effective, is creating virtual workstations that a contributor can spin up on their local machine. So this is a project I worked on last year around election time called Drive the Vote. The idea behind this app was to allow anyone who needed a ride to the voting polls on election day to be matched with a volunteer who would drive them for free. And what we did was we had a Vagrant file within our GitHub repo that allowed someone to quickly spin up a Vagrant box where they could do their development, one, with all the required versions of all the required dependencies already set up for them, and two, they could develop in a way that would be unlikely to affect their local workstation. This means that a contributor could be developing on Linux, Mac, Windows, anything that supports Vagrant, and by spinning up that Vagrant box, instantly be using the exact same development environment as all the other contributors. Now, another option, which we at Chef use with Habitat, is to include a Docker file that can be used to spin up a development environment. So this is the Docker file we have in our Habitat GitHub repo. This provides the configuration for a full development environment within a Docker container. And again, this means a contributor can be using Linux, Macs, Windows, anything that supports Docker, and still have the same development environment as the other contributors. Now, the key to make this successful is to commit to supporting the development environment along with the rest of the project. If the development environment breaks, that means the project is broken, and the first priorities of maintainers needs to be to fix it. In order to fulfill this first duty of making contributing easy, the maintainers of the open source project need to keep the development environment functional at all times. Now, once someone has their development environment set up and makes that change, they then have to test those changes. And as I said before, if dealing with different development environments is a challenge, running tests in different environments is nearly impossible. So the solution to this is to use a continuous integration service like Travis CI or Circle CI. This allows contributors to run automated tests in a consistent environment outside of their workstation and avoids those problems where a test passes on one person's workstation but fails on another person's workstation. So this is the Supermarket project, another project that's created and maintained by Chef Software. Now in this project, we have our Travis CI configuration set up so that every time someone opens a pull request, it automatically kicks off a test run on Travis's hardware. Now once that test run is complete, the results display in the pull request itself. It returns consistent results. And in open source, consistency is a sometimes uncommon but beautiful thing when you can find it. Now, even if someone has an environment set up where running tests locally is difficult, they still have the option to run them just by opening a pull request and seeing the results. It also makes things much easier for the maintainer when they're reviewing the pull request because they can instantly see whether those automated tests passed. So there is certainly more to making contributing to a project easy, but these two parts, setting up the development environment and testing changes, have given me the most grief historically. Luckily, as we just saw, there are solutions which make it easier. Maintaining consistent development and testing environments won't necessarily ever be easy, but these solutions make it possible. That's the first duty of open source governance, making it easy to contribute, making it easier on the contributor side, even if it is not necessarily easy on the maintainer side. Now let's move on to the second duty, assisting users with the project. As an open source maintainer, you are on the front lines of answering requests for help. And most of the time, they come through GitHub issues. These might be bug reports, they might be feature requests. Often they're a combination of both. Now, when the issue is a bug, the hard part is often replicating the issue, especially when your project has many dependencies and is used in many different types of environments. Now, the other hard part is sometimes the issue is not in your project at all, but is due to an upstream dependency of your project. This is also one of the hardest parts, and we'll cover exactly how to deal with that in just a moment. But first, let's talk about replicating an issue. It's especially hard to do this when the person who filed the issue is using the project in a different environment than you are as the maintainer. They might be seeing a bug that only shows up in very specific circumstances. Now, it's never going to be easy, again, but there are some things you can do to make replicating an issue faster and more effective. So let's look at a real-life example of this. This is Test Kitchen, another open source project maintained by Chef. Now, people not only use Test Kitchen in many different environments, they use Test Kitchen to test code, which itself is meant to run in many different environments. So this means the number of possible conditions where someone might see a bug is quite high. Now, when a user sees a bug, we need to know exactly how they are running Test Kitchen in order to be able to diagnose it. And to help with this, Test Kitchen uses a built-in template that auto-populates whenever someone opens a new issue. This lays out exactly what we as the maintainers need to know about a user's environment and tells the user upfront what information they need to provide. It's very hard to miss that you need to provide certain details when this template appears anytime you file an issue in the Test Kitchen repo. Remember, what might be obvious to a maintainer of an open source project is not always obvious to a user, and it's not the user's fault. It saves a lot of time and a lot of back and forth by stating exactly what you need up front where the user cannot miss it. So after reproducing a bug, it's actually fairly common for it to be due to an upstream dependency of the project rather than the code in the project itself. Now, in cases like this, I've seen some maintainers close the issue with words along the line of "not my problem." But if a problem manifests in your project, it is your problem, even if it's due to an external dependency. As a maintainer, it is your responsibility to, 1, communicate the issue to the maintainers of the upstream project, and 2, communicate that to the person or persons who filed the issue in your project. Additionally, you need to update the issue in your project regularly with the progress of fixing the upstream issue. It is your responsibility to keep your users informed and to let them know when the issue is fixed. Now, if the upstream maintainer is ultimately not able to fix the issue, or if you don't get a response from them within a few days, you need to consider changing the dependency. Sometimes a maintainer of an open source project will go dark. That definitely happens. As an open source maintainer yourself, you need to be prepared to change dependencies when needed. So there are certainly more parts to assisting users with open source projects, but these two, replicating the issue and dealing with upstream issues, are some of the hardest, but also some of the most frequent that come up. Dealing with them, again, can be hard, but it is possible. And that covers the second duty of open source governance. So let's go ahead and move on to the third duty, managing contributions to the project. Now, there are two main parts to managing contributions when you are an open source maintainer. And the first is determining whether a contribution adds value to the project. We'll go a little more in depth on exactly how to do that in just a moment. But the other hard part is when a contribution ultimately does not add value, saying no in a way which still supports the contributor and treats both them and their work with empathy and respect. So let's turn our attention to determining whether a pull request adds value. Let's first start with the easy things. Let's go over a few things that definitely add value to a project. And the first one I want to highlight is documentation. This is by far the most useful contribution for me to receive on any projects where I'm a maintainer. This is because there's no better documentation than what comes from someone who is actively using the project. When I'm a maintainer of a project, I become so used to looking at it and understanding it that it's really easy for me to lose sight of someone who does not have my perspective, what they experience. Any contributions which make the experience easier for other users are immediately very valuable. And the next one is typo fixes. Now, occasionally typos sneak into projects. Hopefully not in the actual code that executes, though I have seen that happen, but most often it's in the documentation and instructions. Now, at best, typos make a project look unprofessional. At worst, they can make things like documentation downright misleading and make using the project harder. Again, as a maintainer, I've often been staring at that code and documentation for so long that my eyes just glaze over small typos. Too many typos make a project harder to understand, and therefore corrections to those typos immediately add value. And the last one is small bug fixes. This is another major thing that adds almost immediate value to a project. One of my absolute favorite types of pull requests to receive is when someone finds a bug in the project and reports it by fixing the issue in their own fork and submitting it as a pull request. So whenever a pull request fits into one of these three categories, things that definitely add value, I often merge it that same day, sometimes within the hour, because the value they add is immediate and demonstrable. Now let's talk about the flip side, because there are a few things that definitely do not add value to a project. And the first one I want to highlight is white space changes. This comes up more often than you would think. Unless a project has a style guide and you're correcting a violation to the style guide, white space changes do not add value to a project. My guiding rule is that if it does not violate the established style guide, leave it alone. White space changes, just for the sake of white space changes, cause merge conflicts for other contributors. And therefore, the value they add is actually negative. If I, as a maintainer, receive a pull request that only changes white space, I will not merge it. And the second one that does not add value to a project is big features if you have not talked to the maintainer first. And by a big feature, I'm talking about more than 100 lines of non-test code. This is because it may not fit in with the plan for the project, or it may be something that is already in the works, but not yet public. It is truly heartbreaking to have someone spend a ton of time on a new feature only to have to close it without merging it because it's just not right for the project at that time. Large features, when a contributor has not talked to the maintainer first, do not add value. So now we've covered a few things that definitely add value, and a few that definitely do not add value, and it would be fantastic if all pull requests were this clear. But more often than not, pull requests are for things that sometimes add value. And things that sometimes add value include small features. This is something that's not a bug fix, but something that adds new behavior to the project. And again, I consider a feature small when it is less than 100 lines of non-test code. Additionally, sometimes even large features add value, but only if the person making the feature has talked to the maintainer beforehand. Again, it is heartbreaking when someone has clearly spent a ton of time and effort on a pull request, but as a maintainer, I have to reject it because it's just not right for the project at that time. So these sometimes add value and sometimes do not add value. So this begs the question, how do you determine which is the case at any given time? Well, when a pull request comes in and you're not sure of the value, it helps to ask a few key questions. And the first one I always ask is, does it fix an existing issue? When a pull request fixes an existing issue or fulfills an existing feature request, there is often value in that, especially if multiple people have requested the same thing. Now, the second thing to consider is if the pull request replicates work that has already been done elsewhere. Now, occasionally, multiple people will submit pull requests for the same issue. And then it's up to you as the maintainer to compare them and figure out which solves the issue in the best way for that particular project at that particular time. And the third question to ask is whether it affects in-progress work. If it is something that will potentially cause nasty merge conflicts with development that is already in flight, the value of that pull request might be negative, at least until that in-flight work is complete. The overall guideline is to remember that a contribution returns negative value when it makes other contributions harder. Even if it is something that might actually be the superior option purely from a technical standpoint, if it makes contributions harder or makes using the project harder, it does not add value to the project. Now, when a pull request ultimately does not end up adding value, it's crucial to, one, communicate that, and two, communicate it in a supportive way. Open source projects live and die by community engagement. If someone's first experience with your project is awful, chances are they are not going to come back and may very well warn others to stay away from your project. The key is to always, always, always say thank you. Even if a pull request is something I, as the maintainer of the project, cannot ultimately use, I need to recognize that someone went through the time and effort to put it together and submit it, that the person who opened that pull request is most likely a well-intentioned human being who has taken an interest in my project. In addition to saying thank you, always, always, always say why if you don't merge the pull request. There is little more frustrating for a contributor to spend a ton of time on a pull request, even if it's something they really should have talked to the maintainer about first, and have it just be closed without knowing why. It's frankly cruel to leave your contributors in limbo like that. So these parts of managing contributions, determining the value, and communicating that decision are some of the hardest parts of open source, because they, more than perhaps anything else, touch on that intersection of technology and humanity, both the humans using the technology and the humans creating the technology. Now, even though these parts are the hardest, again, they are the most vital. They are what separate a successful project, a project which lives and evolves and grows that people stay engaged in, from an unsuccessful project where engagement tapers off and the project dies. Now again, open source governance can seem like an impossible job, and it's never going to be easy. But what I hope you take away from this talk is that it is possible to be successful with it. There are tools and techniques out there that can help you, and the key thing, as always, is remembering that the people who make open source projects and contributors are people. There is a person behind the keyboard. Thank you. All right, again, that's my contact info, and I think we have a couple of minutes for some questions. Yes, sir.
As a maintainer, with those large contributions that may not match up, are there general practices or things that you've done in the past successfully to help guide people towards those large things that contribute large value?
That's a good question, and yes, often when, the question was, with things like large features, how do you guide people toward the ones that add value? So whenever a new contributor comes on, or someone's straight out of a coding boot camp and says, I want to get some experience in open source, what I usually do is go through the features and, or the feature requests, find one that might be large, but something that's going to add a lot of value, and then work directly with that potential contributor in breaking it down into achievable steps. That's a great way to, one, make sure that me, the maintainer, and then the contributor are staying in sync with what each other's using, and two, kind of guides them how to do that in the way that might be best for the project. Any other questions? Yes, sir.
How much time do you say you spend in an average day going through different pull requests and actually being a maintainer for Supermarket and Habitat? Do you feel that that's enough time? Do you feel like you should put more effort into it?
The question is, how much time do I as a maintainer spend on things like reviewing pull requests and such for Supermarket and Habitat? I have the luxury of being paid to work on open source full-time. So, and again, it was not always like that. It is a luxury. So I would say there's at least an hour or two of my day job which is spent triaging, which is not necessarily working the issues, but figuring out what people are seeing, where they're being replicated, and then reviewing pull requests. As for reviewing an individual pull request, it depends on the pull request. It's hard to give an approximate value of how much time I would spend on it, because it's highly variable. But yeah, at least a couple of hours of each of my day is spent reviewing things that come into that project, or those projects. Any other questions? Yes, sir. How do I handle requests for deprecation or removal of features? That comes up a lot at Chef. And I pretty much treat it the way I would adding a new feature, but there's more time that I'm going to spend to it because you need to add in a buffer for communicating that that feature is going to be deprecated. In Supermarket, we generally deprecated features with a major release. So we use semantic versioning. So if I was going to take a feature out, I would probably put that in something like version 3.0.0 rather than 3.0.1. So that way it would communicate to the person using the project that there's breaking changes. All right, I think that's all the time we have. I will be at the Chef booth throughout the weekend along with here. So feel free to approach me if you have any questions. Thank you.